Determine whether or not h of x equals 1 over x minus 2 plus 3 is 1 to 1. Now this is actually a transformation of the function f of x equals 1 over x. The first thing that we do is we replace x with x minus 2. We know that's a shift to the right 2 units. And then we take our function and replace it with the function plus 3, which is a shift up 3 units. So really, we need to look at the original function, f of x equals 1 over x, and then shift it. We have graphed the function f of x equals 1 over x before. If you remember, it was asymptotically approaching the x and y axes on 2 different quadrants of the plane. It looked something like this. And my drawing isn't perfect. It's very difficult to draw something that's getting closer and closer to the x-axis and not intersecting with it. However, this function passes the horizontal line test. Any horizontal line intersects this in at most 1 point. And even if it might look like that's not the case here, 1 over x, as x gets bigger, is always getting smaller. So even though it looks like it's almost horizontal, it's never actually moving horizontal. It's always decreasing, getting smaller and smaller and smaller. And on the right side, it's always going to be above the x-axis, and on the left side, it's always below. So this function satisfies the horizontal line test. And if we take the graph and we shift it to the right and we shift it up, the new graph is still going to pass the horizontal line test. We don't even need to graph it. Of course, you can if you want to. But because it's just a translation of a graph that satisfies the horizontal line test, the new graph will as well, and thus our function h of x, it is 1 to 1. Sometimes we don't even need to sketch the graph of a function if we know that it's a transformation of a different function and we know that that function is 1 to 1.